Hey everyone, we're going to review how to do confidence intervals in the form of the Regents questions. We're just going to specifically clarify how to make conclusions from our interval. So we are going to do a few together on this video, and then for the remainder of the period, you're going to do the rest of these on your own. Here we go. In order to decrease the percent of residents who drive to work, so they want to decrease the percent who drive to work, probably because they want to reduce pollution. A large city launches a campaign to encourage people to use public transportation instead. Before starting the campaign, the city's Department of Transportation used census data to estimate that 65% would drive to work. So in the past, the census said that 65% drive to work. That means they polled everyone in the whole population, and 65% of them said they drive to work. So then they conducted a simulation, and this dot plot is based on the simulation results, based on that premise from the census, and they got these results. So we're going to circle on the left. This is the key information we're going to need to make our confidence interval. So it says, using the simulation results, construct a plausible interval containing the middle 95% of the data. So we are going to do a 95% confidence interval based on this data, okay? So let's remind ourselves the formula for confidence interval is center, which is the mean, plus or minus 2 times the standard deviation for a 95% interval. So the mean here is 0.651. So we're going to do 0.651 plus or minus, and then the margin of error is going to be consisting of 2 times this 0.034. Okay, so just remind yourself that this piece after the plus or minus is the margin of error. So now you're going to go to your calculator and you're just going to type in exactly this to get our interval endpoints. 0.651 plus 2 times 0.034, and that's the upper bound, and then go to up, hit enter, and just type over the plus sign, make it a minus sign, and you're going to get your lower boundary of your interval. So let's write it down, 0.583, 0.719. Then what you want to do is look at the italicized words in the question and make sure you round appropriately, because you could get a point off on the Regents just for not rounding correctly. So we're going to get nearest hundredth, which is 2 decimal places. So that's going to be 0.58, comma, 0.72. So basically what this means is I'm 95% confident that the true proportion of residents who drive to work in the city is between 58% and 72%. So that is based on the past census data, based on the simulation, which was based on the past census data, okay? So now we're going to look ahead at the subsequent question. So now down below it says 1 year later, after launching this campaign to try to get more people to not drive to work, they get a survey of 200 residents. So the survey results from this 1 year later, out of 200, 122 of them still drive to work. So if we do the math on that, 122 divided by 200, we get 0.61, or 61% drive to work, okay? They drive to work a year later from that initiative. So now it says, should the department conclude that the city's campaign was effective? Okay, so now let's go back to our old interval. Based on the past, 95%, we were 95% confident that the proportion of people who drive to work is between 58% and 72%. Well, they did it a year later and they found 61% drive to work. So is that much different than what it was in the past? So what you do is you take your 61% and you see if it lies in between that interval. And because it lies in that interval, it's actually consistent with what happened in the past. It's not significantly different than what it was in the past. So basically, they were not effective in improving the percent of people who drive to work or don't drive to work, because 61% lies in the old interval, so it's consistent with what happened in the past. So now we actually have to answer the question. So the question says, should the department conclude that the city's campaign was effective? So we have to answer yes or no. So we want to say no. the city's campaign was not effective. And then we want to say why, because it says explain. So that's where we want to cite that this number, 61%, is in the interval. So it's consistent with the past. It's not significantly different from the past percent who drive to work. Because 61% lies in the interval and is consistent with the past data, with the past census data. Basically, it's not significantly improved from the past because it's still lying in that interval, okay? So I think that making the interval is the easy part. Using the formula for interval is the easy part. You guys can all get 2 points just making that interval, doing this step right here. You guys can all round. And then the hard part is understanding what these words mean, because it could get a little confusing because they use positive and negative language, and you have to understand if it's different or the same. So just try to look at your percent here and say, does it lie in the interval or does it not lie in the interval? And that's really the key to answering the question, okay? So now we go to this multiple choice question, and this multiple choice question is talking about tossing a coin. Specifically, we're tossing a coin 10 times, and we are recording the number of heads. So notice on the x-axis it says the number of heads, not the proportion of heads. And then we're going to repeat this 50 times. So this is actually 50 dots. And each dot represents either me like physically flipping the coin 50 times or me simulating flipping the coin 50 times with my calculator. And then it says, based on the results of this simulation, which statement is false? So I would really go through all these and read them all and write true or false next to each one and try to find the one that's false. So it says 5 heads occurred the most often. So do you guys agree 5 heads did occur the most often? And that is consistent with the theoretical probability of obtaining heads. So you guys should know that theoretically the probability of getting heads is 1/2 or 50%, and 50% of 10 coin flips should be 5 heads. So that is what we thought we were going to get, and that's what was most often. So this is true. So remember, if it's true, it's out because it says which is false. 8 heads is unusual as it falls outside of the middle 95%. Does 8 heads look unusual to you? Do you think it falls outside of the middle 95%? I'm not sure. I'm going to hold on to that one. I got to actually find the middle 95%. Number 3, obtaining the 3 heads or fewer occurs 28% of the time. 3 heads or fewer, that would be less than or equal to 3 heads, occurs 28% of the time. I guess I have to count these dots here. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 dots out of how many total dots? 50 dots. So let's do the math. 14 divided by 50 equals 28%. Oh, this is true. So this is out because it's true. It says which is false, right? And 4, 7 heads is not unusual as it falls within the middle 95% of the data. So does 7 heads fall within the middle 95% of the data? It probably does, but maybe let's figure it out right now. So there are 50 total dots, right? So we have to find 95% of 50. To do that, we are going to do 0.95 times 50 to figure out the middle 95% of the data, okay? So let's do 0.95 times 50, and we get 47.5. So the middle 47.5 dots are the middle 95%, which, you know, that's annoying to count 47 dots, 0.5, but the complement of that would be 5%, which is like the outer 5%. So if you did 5% of 50, you would get 2.5. So like the ones that aren't in the middle 95% are the outer 2.5 dots. So if you want to think about it that way, here's 1, here's 2, here's 3. So those are not in the middle 95%, which means that the middle 95% of the data is all of these dots. It should be about 47.5-ish dots. It's 47 dots. But this is the middle 95% of the data, okay? So anything in that middle chunk, anything that is in this middle chunk is common. Another name for it is not unusual. It is likely to occur. So now let's look at 4 and 2. 4 says 7 heads is not unusual because it falls in the middle 95%. Does 7 heads fall in the middle 95%? It does. It's likely to happen. So that's a true statement, which means it's out. So it's got to be choice 2, which says 8 heads is unusual because it falls outside of the middle 95%. 8 heads actually does not fall outside of the middle 95%. It falls within it. So that's why choice 2 is false. Yikes, what a multiple choice question. That one was tricky. Last one, I'm going to do with you. Number 3, a radio station claims its advertisers have a mean number of minutes commuters listen to is 30. So they claim that the true mean number of minutes that they're listening to is 30 minutes. Okay, that's their claim. So now they conduct a survey, and out of the survey, they get the sample mean. This is X bar, sample mean of 29-ish. And that came from the sample. So we call it X bar instead of mu. And then notice here you have S, which is the sample standard deviation. Now we're going to run a simulation. And the simulation is run 1,000 times based on the result of the survey. Here it is. Based on the simulation results, is the claim that the commuters listen to 30 plausible or accurate? Explain your response by including an interval for the middle 95% of the data. So they want you to use this data. They do not want to use the above data. So you're like, why'd they even give me the above data? Use this data for your interval. Okay, so we're going to do our confidence interval. Here we go. Statistic, mean. Just kidding. Mean plus or minus 2 times the standard deviation. The mean was 29.101 plus or minus 2 times 0.934. Okay, now we're going to actually find it. I'm going to pause the video and find it now for you. So my answer, I got 27.233. It says nearest hundredth. So I got 27.23 and 30.97. 27.23 and comma 30.97. And this is in minutes because they're talking about the minutes that the average customer listens to the radio station. So I'm 95% confident that the average listener will listen to the radio station between 27.23 minutes and 30.97 minutes. So I'm done with this part. And now I move on to answering the question that is interpreting the interval. So they're saying based on the result from our simulation, based on our interval here, is the claim that customers listen on average for 30 minutes plausible. So another name for plausible is likely or reasonable. So is it likely that the customers will listen for about 30 minutes? And the answer you should be saying is yes, because 30 minutes is within the interval, it is likely. Remember, if it's in that middle chunk, it is likely. If it is in the tails, it is rare or unlikely. So 30 is within the interval, thus it is likely. So we have to answer the question yes or no. Is the claim plausible? We want to say yes. The claim is plausible because 30 minutes lies within the interval. Within the 95% interval, meaning that it is within the middle 95% of the data. All right, that's it. Now I want you guys to go do the rest. Do not stop here. do these now. Start with the one with Elizabeth and work your way through. I will be checking that you tried a few more.